You can find out which versions of Android are in most current use at this webpage at developer.android.com/about/dashboards. There are a number of ways to make an app adapt to different screen sizes, pixel densities, and orientations. I'll start by describing a simple technique for providing an alternative layout file that'll be used when a device switches between portrait and landscape orientations. In the current version of my app, I have an About activity. I have a graphic at the top and then two text views. And the second text view is wrapped inside a scroll view, so when I have long text, I can scroll it vertically. But when I turn the device sideways, it doesn't look so great in landscape orientation. The elements are stacked exactly the same way, but the long text now expands to fill the entire screen, and it only has a little bit of vertical visibility. I'd like to have an alternative layout that will take effect when I'm in landscape orientation. To do this, I'll create a copy of my content-about.xml file. It'll go into a new directory that'll be named layout-land. And then, when the device is in landscape orientation, the application framework will automatically choose that layout file. I could do this manually, creating the directory and copying the file, but Android Studio will do the work for me. I've opened the layout file and I'm looking at it in design mode, and I'll pull down this menu from the toolbar and choose Create Landscape Variation. That opens a new version of the file, and on the tab you'll see that it's prefixed with the directory name of land. But when I float the cursor over the tab, I'll see the actual location, and in the project window, I'll see that there are now two versions of the layout file, one marked with land in parentheses. I'll look at that same file in the project view that shows me the actual directory structure on disk, and I'll see that this is actually in a directory named layout-land. So now I'll make some changes to this layout. For the image view, I'll get rid of the center horizontal and margin bottom settings, and I'll replace those with a few other alignment and margin settings. First, I'll set a value of align parent left, and I'll set that value to true. For right to left layouts, I'll also add align parent start and set it to a true value as well. Next, I'll set a 10 pixel margin on the right side of the image, so this will create a little bit of space between the image, which will be on the left, and all of the text that will be on the right. I'll set layout margin right to 10 dp, and then I'll also add layout margin end and also set that to 10 dp. And again, that's to take care of any right to left layouts. Next, I'll go to the first text view. This is the headline, and I'll make these changes. I no longer want this text view to be below the image. Instead, I want it to be to its right. So I'll change this setting to layout to right of, and then I'll duplicate that setting and make this one layout to end of. So I'm anchoring the text view to the right of the image. I'll keep margin bottom set to 10 dp because that's creating the space between this text view and the scrolling text. Now I'll go to the scroll view and I'll make some changes here as well. I still want the scroll view to be below the headline, so I'll leave that setting in place. But I'll also add a setting called Layout Align Left. And I'll anchor it to the headline, and that's to make sure that the two text view controls align with each other on their left edges. And then once again, for right to left rendering, I'll add Layout Align Start. And I'll look at that in preview, and I like what I'm seeing. So now I'll run the app on the device. When the app opens, I'll go to my Options menu and choose About, and there's the portrait rendering, and now I'll turn the device landscape, and I'll see that it automatically picks up my new landscape layout, and I can scroll and read all of the text. And I'll turn it back again to portrait, and I see the portrait layout. So that's one example of how you can use resource directory names to control behavior at runtime. If you take any resource directory name such as layout or values and you append -land, the files or the values that are defined in the landscape version of the directory will override the default values or files. And you can look at the documentation for lots of examples of this that are supported by the Android Application Framework. You can use specially named Dimensions resource folders to manage what happens on large screen devices. When you create a brand new Android Studio project, you'll have two files named dimens.xml. The default one has settings named Activity Horizontal Margin and Activity Vertical Margin, and depending on the template, you might also have a margin for the floating action button. There's an alternative file in a folder that ends with W820DP, and this has an alternative setting for the horizontal margin. This will override the settings on a screen with more than 820 device-independent pixels of available width, and this would take effect in both a landscape and a portrait setting on, say, a Nexus 9 tablet. I'll demonstrate this in the project Alternative Dimens, and I'm going to start in one of my Content About files. Remember that I have two of these files now, one for portrait and one for landscape, and I'll start in the default one for the portrait orientation. I'll go to my first text view control, where I've set my headline size to 24SP. I'll select that value and then use an intention action and extract that value as a dimension resource. I'll name it headline_size. Then I'll copy that value and I'll go over to the landscape version and I'll replace the literal value 24SP with the new dimension resource. I'll Control or Command click and show that that value has been created in my default dimens.xml file. Now I'll go back to my default layout file and I'll add a text size setting to the long text view, and I'll set that to a value of 14SP. Then once again, I'll extract that as a dimension resource, and I'll name this content size, and then I'll select this entire attribute and copy it, and I'll go to my alternative layout for landscape orientation and paste that in. So far, all I've done is to abstract my values out to dimension resources, but the behavior should be exactly the same. In order to test all this out, I created a new virtual device that emulates the Nexus 9 tablet, and I'm already running it on my screen, along with projecting my physical phone device to the screen, the Nexus 5X. And I'm going to run the app on both devices at the same time. When I click the Run button and I see the Device Chooser dialog, I'll press Shift and select both devices and then click OK. When the app opens on both devices, I'll go to the About screen, first on the physical device, and then I'll use my mouse on the virtual device, and I'll show that with exactly the same layout and settings, this looks pretty good on the phone, but the text is clearly too small on a tablet. So here's how I'll fix it. I'll go back to Android Studio, and I'm going to select these two dimension settings from my default dimensions file. I'll copy them to the clipboard. Then I'll go to the alternative dimensions file, and I'll paste those values in. And I'm going to change those values. I'll set my headline size for the tablet to 48SP and the content size to 24SP. And then I'll run the app again on both devices. On the phone, the display is the same as before. But now on the tablet, the text is much larger and much more readable. And with the emulator, you can test this in different orientations by pressing Ctrl F11. Now notice when I go to portrait mode with the tablet, the text goes back to the small size. And that's because with the tablet in portrait mode, it no longer satisfies the requirements for that particular directory. So you might try renaming that special directory or creating yet another directory that handles this particular situation. But either way, you see the pattern, that just like with orientation, you can create specially named resource directories to contain alternative definition files for layouts, dimensions, and other kinds of values. I've previously described ways of creating alternative images, both for the launcher icon and for icons that you use in the action bar. In both cases, folders were created under Resources for the different pixel density buckets, and it's up to the application framework to decide which version of a PNG or JPG file to use at runtime, depending on the device's capabilities. You can do the same thing with other kinds of images, but Android Studio won't handle it for you. If you try to create a new image asset in Android Studio, you'll see that there are options for 3 different kinds of asset types, but they're all icons. None of them are simple images. So if you want to generate different size images for different screens, you'll need another tool. There are a few different tools available that have been created by community members. I'll show you my favorite. It's at this website. On github.com, you can clone this onto your desktop or download it using Git, but I've just downloaded the jar file, so I can run it on my desktop. If you have a Java runtime installed on your computer, you can double-click the jar file and run the application. Then start with the base graphic. I'm going to go to my exercise files folder, to Assets, to Logo, and I'll choose this logo file. I'll copy it and I'll paste it to my desktop, just creating a temporary version. Then I'll create a new folder on my desktop that I'll call Images. You can actually name this folder anything you want. Now I'll go to Final Android Resizer, and I'll browse, and I'll choose my new folder. Desktop/Images under my Home folder. Now I'm ready to generate the different size images for the different pixel density buckets. I'll indicate the input density, and this isn't based on the size of the image, it's based on the number of pixels per inch. I'll choose XX HDPI. Then I'll select the pixel density buckets I want to create. Because I'm not going to support very old Android devices, I'll deselect the option for LDPI, but I'll accept everything else. I won't select TV DPI for TV factors. Then I'll drag and drop my original image onto the application. And after just a moment, a whole bunch of new versions of the image have been created, each in their own pixel density folder. So there's the XX HDPI version, the XXX, and so on. Now, I'm going to open these side by side so we can see the difference. That's the XXX version, the very high density version. And then I'll go to the medium density version, and I'll see that the medium density is 6.3 KB, and the high density version is 43 KB. So a lower density image will be smaller. That makes sense. Now I'm going to copy these files into my project. I'll go into the Images folder and select all of the drawable folders, and I'll copy those to the clipboard. Then I'll go back to Android Studio, and I'll make sure that I've selected the Resources folder, and I'll paste. And when I see the copy dialog, I'll click OK to confirm. And that creates all 5 versions of my logo file in the different pixel density buckets. Then I'll delete the original version. I'll select the file and press delete, and I see this dialog. If these options are selected, just deselect Safe Delete. You don't need to worry about any usages of the file because you're replacing that original file with all the different pixel density versions. I'll click OK, and I still have my 5 different versions. On Windows, you might see a couple of thumbsdb files created if you've been following along. Those are artifacts of Windows that aren't a part of the Android app, so you can simply delete them. And now I'm ready to test the app again. As before, I'm running the app on 2 devices, a phone and a tablet. On both devices, I'll go to the About screen, and you won't see anything significantly different about the 2 devices. But if you were looking at actual devices with the human eye, you might see different resolutions on the 2 devices and they would look to the human eye like they were the same image. And if you went into the layout files and removed the dimensions that are affecting the size of the image views, then you would see on the two devices that the phone displayed a smaller image and the tablet displayed a larger image relative to the sizes of their screens. So again, this is an example of using specially named resource folders to store different versions of a file. I'll go once again to my project view and then drill down to my resources folder. And I've shown how to create multiple versions of images in different drawable folders, how to create different versions of layouts, and also how to override dimension values in different versions of the values folder. There's another entire aspect of working with multiple screens that involves designing layouts with fragments. This is a large subject, and really it's beyond the scope of this beginning course, but I'd like to show you some basic ideas around fragments and how they can be used to make an app truly flexible. Once again, I'm working with two devices, a physical phone that I'm projecting to the screen on the right, and an Android virtual device emulating a Nexus 9 tablet. I'll go to Android Studio's welcome screen, and I'll go to the beginning screen and start a new Android Studio project. I'll name this new application Fragment App. I won't worry about the package name. This is going to be completely a temporary application, and I'll place it on my desktop. I'll accept the form factors and the minimum SDK, and then on the activity screen, once again, I'll choose blank activity, but then this time, on this screen, I'll select the option Use a Fragment, and click Finish to create the project. As before, the project opens to the preview of the layout screen. But if I look at the layout folder in my resources folder, I'll now see that there are 3 layout files there. Activity_main, which once again contains my coordinator layout, my application bar controls, and the include for the content file, and contentMain.xml. But this time, contentMain.xml has a fragment element, and it points to a Java class named MainActivityFragment. The MainActivityFragment class has an onCreateView method, and it loads its own layout called fragment_main, and that's this file. Now, the reason you do things in this way is so you can put together an application layout dynamically at runtime. In this beginning application, this app is always going to look exactly the same, no matter what kind of device it's run on. And in fact, I'll run this app on both my phone and my tablet. In the device chooser, I'll choose both devices. And then when the app loads, I'll see that it looks pretty much the same. You will see a difference in the horizontal margin here. There's more space in the tablet than there is in the phone, but that's not because of the fragment. That's because of the special dimens.xml file that overrides that setting for larger screens. You can more clearly see the advantages of working with fragments by creating another new application that's based on a template called the Master Detail template. I'll close this project, and I'll create yet another Android Studio project, and I'll call it Master Detail. I'll accept all of these settings on the Form Factors and Minimum SDK screen, and this time on the Activity Selection screen, I'll choose Master Detail Flow. And I'll accept all of the settings on this screen and click Finish. Now this project has a lot more layout files. In fact, it has 5 layout files. There are 4 primary XML files. There's one called Activity Item List, and that contains a reference to a fragment. And then there's Fragment Item Detail, Activity Item Detail, and Activity Item App Bar. Now here's what's happening in this application. When you open the application, this Java class, Item List Activity, starts up. That's the launcher class. And then it goes and looks for a particular element. If it finds a particular element in a layout file on this line, then it decides it's in what's called 2-pane mode. If it doesn't, then it's in a single pane mode. And that's activated by these two alternative activity item list XML files. One of them, that's designed for tablets, has a reference to a fragment that in turn references an ID of item_list. So here's how it ends up behaving on the two different devices. Once again, I'll run the app on two devices. On the phone device on the right, which is a physical device that I'm projecting to the screen, when I touch an item, I go to a completely different activity. And that activity has a lot of flexibility in the layout. I can click on the divider and drag it up and down. That's being managed by that coordinator layout control. And then when I touch the back button, I go back to the list view. But on the tablet, when I touch an item, I see the details right there on the same screen. I'm now in two-pane mode, as it's known in my Java code. And the way this is working is that there's a single fragment. This fragment layout is being used both on the tablet and on the phone, but it's being seen in a different context, depending on the size of the screen. There's a certain amount of complexity involved in getting started with fragment-based applications. So if this is interesting to you, I recommend looking at the course on building fragment-based Android apps. There are many kinds of Android apps where you need to display a list of data that scrolls whenever there's too much data to fit on the screen. I'm going to show you how to display a list of simple strings, and then in later videos, I'll expand that to more customized displays. I'm working in a project named ListView, and I'll show you in the Values folder under Resources that I've added a new file called clothing.xml. This resource definition file declares a string array. Now, we haven't seen this before, but a string array is exactly what it says, a collection of string values. And because it's an array, it stores the data in a fixed order. This is a great way to provide a small amount of data to an application where the data won't be dynamic. That is, you won't be getting the data from a server or otherwise changing it at runtime. Just like all resources, you have to assign an ID, and I've assigned a resource ID of clothing. Next, I'll go to my layout file, contentmain.xml, and I'm going to delete this image view control, and I'll replace it with a list view. You can find this in the palette under Containers, and I'm going to drag and drop it into place and place it in the top left corner of the activity. Then, I'll go to text mode and take a look at the generated code. I'm going to change the width and the height from wrap content to match parent so that the list view always expands to fill the available space. Then I'm going to reformat my code to place things in the right order, and then add a little bit of space here, and then look at it in Design View again. That's all I have to do in the layout file. All the rest of the work will be in Java code. I'll find my main activity class, and I'll scroll down to the bottom of the onCreate method. This is where I'll add the code that gets the data from the resources file and passes it to that list view control. First, I'll declare an array of strings. I'll name it items, and I'll use this expression to retrieve it from the resources file. I'll start with the method getResources. Then from there, I'll call a method named getStringArray, and then I'll pass in an ID. With a simple string, the resource ID always starts with r.string, but with an array, it starts with r.array. So I'll pass in r.array.clothing. And because that process is running in the background, scanning my code and generating the Java classes, Android Studio already knows that that resource ID exists. Next, I'll create an instance of a class called an array adapter. This is a member of the package Android.widget, and it's this class that's going to bind the data to the list. The array adapter has a generic type declaration. You set this to the type of data you're passing in. I'm working with an array of strings, so I'll set my generic declaration to string. And I'll name the object adapter. Next, I'll instantiate the object using the ArrayAdapter's constructor method, and I'm going to use a version of this constructor that requires a lot of information. First, you always have to pass in the context. That's this activity. So I'll pass in this. Next, I'm going to pass in a resource identifier for a layout file. Now, this isn't a layout file that I created. This will be a layout file that's included with the Android SDK. These identifiers always start with Android, lowercase, and then .r. And then I'm looking for a layout file, and the particular file I'm going to use is called Simple List Item 1. This layout file contains a single text view component. Let's take a look at its code. I'll press Control or Command and click into the file, and then look at it in Code View, and I see that all it has is a single text view. And importantly, it has an ID of text1. Notice that the ID starts with @Android:ID. So this is how the IDs that are built into the SDK are declared. I'll come back to my code. The next value I'm going to pass in is the ID of the text view that will display my string for a single row. And that will be Android.r.id.text1. And again, I know that because I looked at the code for that layout. And finally, I need to pass in the objects that I'm going to be displaying. This can either be a simple array of strings or a complex list of strings. And I'll pass in my array of strings that I named items. So now the adapter knows what data it's using, it knows what layout it's using for each row in the list, and it knows what the ID of the text view is to display a string. Next, I'll get a reference to my list view component that's a part of my layout. I'll type in list view, that's the name of the class, and press Control Space and choose it from the list to be sure it's imported into my Java class. I'll name it LV for list view, and then I'll call findViewById and pass in the ID of the list view. That's r.id.listView. And as always, I'll cast the return value as the appropriate class. Now, if you're wondering where that ID came from, it's actually in my layout. When I dragged the list view into my layout, this ID was generated for me. And now finally, I'm ready to bind everything together. And for that, I'll call lv.setAdapter, and I'll pass in the adapter object. So it takes about 4 statements. Get the data, create the adapter, get the reference to the list view, and then connect the adapter to the list view. And I'll run the app and see the result. When the app comes to the screen, the onCreate method is executed and all that code is executed to go get the data and display it. Now, when I'm looking at the phone in portrait orientation, the data isn't scrolling because everything is fitting on the screen. So I'll turn the phone sideways to landscape, and now I'm only seeing a portion of the data, but I can touch the screen and drag up and down to scroll. And then I'll go back to portrait. So that's how easy it is to display data in a scrolling list in Android. You start off with a data collection, which can be either a simple array or a Java list, and then you use an adapter and a list view. So far, my application is displaying a simple list of strings, but I'd like to make this more visually interesting and also support more complex data. So I'm now working with a version of my project named Customize List, and I'm going to customize the list display to show a variety of text values and some photos. In this version of the project, I've added a number of assets. First of all, I've created an assets folder. As I showed in a previous video in this course, an assets folder can contain images and other files that you want to incorporate into your app. These image files don't have resource IDs. Instead, I'll be addressing them by their file names. I've also added a couple of Java classes. The product class represents a complex object with 4 values, 3 strings and a double numeric. The strings are product ID, name, and description, and the numeric value is a price value. There are getter methods for each of these fields and a constructor method that lets me create instances of the class. And then there's a class named Data Provider. This class is creating a list of complex objects, and each object is an instance of that product class. It then exposes that data in the form of two static fields, a list and a map. The list is just an ordered list of data, and the map is a set of key-value pairs, where the key is a string and the associated item is an instance of that product class. Finally, I've added one new layout file. It's called listitem.xml. This layout will be used to represent each row of my list. It'll start with an image view component on the left, and then a linear layout on the right that's stacked vertically. Within the linear layout, there are two text views, one for the name of a clothing item and one for the price. And each of those text views has some dummy text that will allow me to see what the design looks like. Each row of the list item will look like this, with the image on the left and the two text values on the right stacked vertically. So here's how we're going to bind it all together. Currently, in my main activity class, as the activity starts up, I'm creating an instance of the ArrayAdapter class. This adapter is designed to contain instances of the string class, and then I'm using a layout that comes from the Android SDK, and that's how I'm getting a simple list of strings. I'm going to replace this ArrayAdapter with my own custom ArrayAdapter, and it'll know how to deal with my product class and with the layout file that I created. So for this demonstration, I'll start in the base package of my Java folder, and I'll right-click on the package and create a new Java class. I'll name it Product List Adapter. I'll get rid of this automatically generated comment, and then I'll add an extends clause. And I'm going to extend the ArrayAdapter class, but this particular superclass is going to set its generic type as product. And that's my custom product class. So my custom adapter class is a subclass of the ArrayAdapter class, and it'll be designed to deal with a list of product items. Notice the error indicator, and I'll use an intention action, and I'll see that there's a suggestion to create a constructor matching the superclass. I'll select that, and I'll see that there are many different constructors. I'm going to use this one that accepts three arguments: a context, a resource ID, and a set of objects. Now, you might not see all of this syntax on your screen, but you can click and drag to the right to open up this dialog a little bit further. I'll select that version of the constructor and click OK. As this constructor method is called, it'll be receiving an array of products, but I want to change that. Instead of a simple array, I want this to be a list of products, because that's how I'll be getting the data from my Data Provider class. So I'll change this to a list, and I'll set the type of item that the list contains to product. And I'll be sure to have imported the list interface up here. Next, I'll declare a list of products as a private field of this class. And I'll name it products. Then, as the constructor method is called, I'll save the reference to the data here by saying products equals objects. And now I have a persistent reference to all the data I need. Next, I need to override a method named getView. This method will be called automatically as the user scrolls up and down in the list, and each time the method is called, it'll be up to me to take data from the current product and then display it in one of the visual controls in my list item layout. I'll type the beginning of the method name, getView, and then I'll select it from the list. And I'll be adding all of my custom code here. As the getView method is called, I'm receiving something called a convertView parameter. This will either be null or it'll represent a layout that's already been created. That's because the list view control will be recycling the views so that you're not always creating new instances of the view for every row that the user sees. So I'll use a little bit of conditional code here, and I'll find out whether the current view is null. And if it is, I'll instantiate it. I'll say convertView equals, and then I'll call the layout inflator class. We've used this class before to inflate a layout as an activity starts up, and this time I'm going to use a bit of syntax that looks like this. LayoutInflator.from, and then it wants a context, so I'll pass in getContext. Then I'll move the cursor to the end of this expression and put in a dot, and then on the next line I'll call a method named inflate, and I'll refer to that new custom layout, r.layout.listItem. I'll pass in two more arguments. First, parent, the parameter that's passed in for the current view group, and then a value of false for the Boolean value attached to root. So now I have a layout that I can work with. And next comes all the work I need to do to take values from the current data item and assign them to the visual controls. Notice that as the getView method is called, I'm receiving a position argument, an integer value. This tells me the current position of the required data item for the current row in the list view. I'll use that to get the current product item from the data. I'll declare a variable data typed as product, and I'll name it product, and I'll get its value with products.get, and I'll pass in position. So now I have a reference to a product item, and I want to display the title of the product. I'll create a text view object, and I'll name it nameText. This will represent the name of the current clothing item. I'll get the reference to this text view by calling convertView.findViewById, and I'll pass in r.id.nameText. And I'll cast the return value as a text view object. Then I'll say nameText.setText, and I'll pass in product.getName. So I'm calling a getter method from my product item. Then I'll come down here to the return statement, and I'll return the reference to the convertView object. Now that's all I'm going to do in terms of assigning values to visual controls for this demonstration. I'll show you how to customize the other controls later on. But next, I'll go to my main activity class, and I'm going to change my code that's creating the array adapter that binds the data to the list view. I'll comment out this version that's using the standard array adapter class. And up here I'm going to create a private field that's an instance of the list interface that contains products. And once again, I'll name it products. And I'll get its value by calling the data provider class's product list field. So now I have a persistent reference to the data I want to work with. And I'll come back down here to my onCreate method, and I'll create an instance of my custom product list adapter class. I'll name it adapter just like I did before, and I'll instantiate it with new product list adapter. I need 3 arguments. I'll pass in this for the context, and then r.layout.list_item as the layout resource, and then finally my products. I'll close up the code and then make sure I don't have any errors. And I'm ready for my first test of this new list display. And there's the result. Currently, I'm displaying the same image and price for every list item, but I'm successfully displaying the customized name of each product. And so now my next step will be to customize the price display and the image. And I'll show you how to do that in the next video. So far, I've customized my list display to the extent that I'm displaying a variety of product names, but right now I'm still seeing the dummy values for a price and for an image. And now I'll further customize my Java code. I'm now working in a version of the project named Customize Controls. You can either load this project or continue with the previous one. And I'll be making changes to the Product List Adapter class. My data is being stored in instances of this class product, and the price is being stored as a Java double value. I want to format that as a currency value, and I'll use some pretty conventional Java code to do that. First, I'll create an instance of the Java number format class. It's a member of the package java.text, and I'll name it formatter. And I'll get its reference with number format, and then I'll call the method getCurrencyInstance. If you want to internationalize your app, you can set the currency instance to a particular locale. Next, I'll create a string that I'll name price, and I'll get its value by formatting the numeric value with formatter.format, and then I'll pass in the price from product.getPrice. Now I'm ready to display that value. As I did before, I'll get a reference to the required text view object in the layout. I'll name this one priceText, and I'll get its value by calling convertView.findViewById, and I'll pass in r.id.priceText, and I'll cast the return value. Then I'll say priceText.setText, and I'll pass in the price. And then I'll run the code again and see how I'm doing. And now I see the correct price displayed with each item. I'll return to my Java code, and now I'll add code to load images dynamically. To do this, I'm going to add another method down here. The amount of code you need to load a bitmap is enough that I'll want to separate it into its own method. I'll make this method private, and it'll return an instance of the bitmap class from the Android.graphics package. And I'll name it getBitmapFromAsset. I'm going to take a string value that I'll be getting from this product class. And that string value is set up in the data provider here. In each of these product items, the product ID matches the name of one of these PNG files. So, shirt101 matches this PNG file, shirt101.png, and so on. So, in order to get a bitmap, I need the product ID. And I'll declare a single argument, which I'll name product ID. Next, I'll add code that I demonstrated earlier in the course, getting an asset from the assets folder, but this time I'm doing it dynamically based on a string that's passed in. I'll get a reference to the Asset Manager class. I'll call getContext.getAssets. Next, I'll create an input stream, and this is from the java.io package, and I'll set it up initially as null. Next, I'll call stream equals assetmanager.open, and then I'll pass in a concatenated string, starting with the product ID and ending with the file extension .png. The error indicator is there because this could throw an exception, so I'll use an intention action and I'll surround that code with a try-catch block. If I get the stream successfully, then I can return the bitmap with this expression. I'll use the bitmap factory class from Android.graphics, and I'll call decodeStream, and I'll pass in the stream. If I get into the catch block, though, I'll return null. So now I have a method that can go get a bitmap based on the product ID. Now I'll display that image in my ImageView component. I'll get my reference to the ImageView by declaring an instance of the ImageView class that I'll name IV, and then once again I'll call convertView.findViewById, and I'll pass in the ID in the layout r.id.ImageView, and I'll cast the return value. Next, I'll declare my bitmap reference. I'll declare an instance of the bitmap class, and I'll get its value by calling my custom method getBitmapFromAsset, and I'll pass in product.getProductID. And then I'll display that image with iv.setImageBitmap, and I'll pass in the bitmap object. So now I've overridden the default displays of both text views and of the image view, and I'll run the code again. And there's the result. I'm now seeing the correct image for each product item along with its name and its unique price. When a user touches an item on a list, they expect to see the details of the selected item. There are a few ways to do this in Android, but the simplest is to navigate to another activity, known as the Detail activity, and display the details there. Right now, I can scroll up and down in my list, and I can touch an item, and I see a little bit of visual feedback that I'm touching the item, but nothing else is happening. In order to see the details, I'll create the new activity, and then I'll add code to navigate to that activity. I'm now working in a version of the project named Detail Activity. And I'll start by creating the new activity here. I'll select File, New, Activity, and I'll choose the blank activity template. And I'll set the activity name to Detail Activity. This won't be the launcher activity, it won't be the activity that initially comes to the screen, and I won't be using a fragment. I will set the hierarchical parent, though, to main activity, and that means that when I return from this activity, I'll come back to the main screen. And I'll click Finish. That creates a few new files. First, there's the Detail Activity class. As with other activities, it extends app-compat-activity. It loads a new layout file, Activity Detail, and because it's a secondary activity, it has the code to display the up icon. I'll click into the layout file, Activity Detail, and show that in Code View, and show that it's an identical file to the other activity files. It has the coordinator layout, and the toolbar, and a floating action button which you can either choose to keep or delete. And it has an include that takes me to contentdetail.xml, and this file has just a relative layout. This is where you'll put your visual controls to display the details of the selected data. Now this will take quite a bit of code, so I've posted that code in a gist. That's a code snippet on GitHub, and you can get to it with this URL. I'll select and copy all of this XML code for the XML file. Then I'll go back to Android Studio, and I'll select and delete all the code in the initial file, and I'll paste in the code from the gist. Now the file has a reference to a non-existent string here named lorem ipsum, and I'm going to replace that with a reference to the string about_text. This text won't actually be displayed when we look at the details. That'll come from the selected clothing item, but this is just for viewing the layout in Design View. Here are the components that are included in this layout. There's a text view here for the product name, and then another text view for the price. Then, just like in the About activity, I have a scroll view wrapped around a text view, and that's for the long scrolling text. And finally, an image view to display the selected image. If I look at that in Design View, I see an approximation of what this activity will look like. Now I need to add code in my main activity class to go to that activity when the user selects an item from the list. I'll scroll down to the end of my onCreate method, and I'll add code to handle a method named onItemClickListener. I'll call this method from the LV object, that's the list view, and I'll call setOnItemClickListener, and I'll pass in an anonymous implementation of an interface named onItemClickListener. I'll type the beginning of the interface name and then select it, and that expands to include an override of the method onItemClick. Now notice, very importantly, that the name of this method is onItemClickListener and not just onClickListener. You use onClickListener for buttons and other individual objects. But when you're working with something called an adapter view, which is what a list view is, you need to use onItemClickListener so that you're implementing this event handler for each item in the list. Within the method, I'll add this code. I'll create an intent object. And as I've done previously, I'll instantiate it using the intent constructor, and I'll use a version that requires a context and a class. For the context, I'll use the expression main_activity.this. I can't just pass in this because that would reference the ClickListener object. I want to reference the activity. And then I'll pass in detailActivity.class, which means I want to create an instance of that class and display that. Then I'll call the method startActivity and pass in the intent. Now, so far, I'm not customizing the detail activity for the selected item from the list. I'll do that later, but I'll test this much code to make sure I'm jumping to that activity. And now I can touch any item in the list, and I'll jump to the detail activity. And when I press the device back button or the up icon on the action bar, that will result in going back to the main activity. So far, so good. I now am navigating between the activities, but now I need to customize that detail activity to display the details of the selected item. When navigating from one activity to another, you can pass data as an extra. An extra can be of one of the common Java data types, strings, numbers, and booleans, and you can also pass arrays of those types, and you can even pass collections of name-value pairs known as bundles, a kind of hash map. In this demonstration, I'll pass a single value from my main activity to my detail activity, and then in the detail activity I'll use that value to get a complex object from my data provider. And from there, I'll be able to display all of the requested details. I'm working in the project Display Details now, and I'll start in the main activity class. I'll go to the code that's opening my detail activity. It's in the setOnItemClickListener method down here. I'm going to add code here after I've created my intent object. And I'm going to get a reference to the current product that the user selected. I'll create a variable typed as product, and I'll name it product, lowercase, and I'll get its value by calling the get method of my product list and passing in the position argument that's passed into the onItemClick method. I'll call products.get and then position. So now I have the complex product itself. I could break this down and pass all the values from the product. Remember that it has 4 different fields, but I'm going to go with a simpler approach. I'm only going to pass the product ID, essentially the primary key, and then I'll leave it up to the detail activity to decide what to do with that. So next, I'll pass data into the intent object. I'll call a method named intent.putExtra. You'll see a number of different versions of this method. Each of them has a first argument typed as a string. That's the name of the extra. And then the second argument is one of a number of different types. Again, the primitives and other simple types of Java, or a bundle, a hash map. I'm going to choose this version, where I'm passing in a string for the name and a character sequence or a string for the value. I'm going to need to access the name from 2 activities, so I'll set up a constant for that. I'll name it product_ID for the name of the field I'm passing. Now that constant doesn't exist yet, so after typing in the name, I'll use an intention action, and I'll create the constant field constantID as a member of the main activity class. I'll tab over and assign a string. This could be anything you want, but I'll set it as the same as the name of the constant. Then I'll press Alt or Option and then F7, and then I can jump back to where I'm using that constant down here. Next, I'll pass in the value that I want to send to the detail activity. That'll be product.getProductID. So now I've passed the value into the intent, and the intent starts the activity, and the detail activity can receive that value. I'll go to the detail activity class, and I'll add code right here. before I work on my floating action button and everything else. First, I need to retrieve that extra value. I'll create a string variable that once again I'll name product ID. And I'll use this expression to go get the value. First, I'll call a method named getIntent. That returns a reference to the intent object that launched this activity. Then I'll call a method named getStringExtra. Notice that there's a getBooleanExtra and a getByteExtra and getIntExtra and so on. So when you put the extra in from the sending activity, you always call putExtra. But when you're receiving the extra, you need to know what type you're looking for. I'll call getStringExtra, and now I need to pass in the name or the key of the extra value. And I'll get that from the main activity's constant that I just created, mainActivity.productID. Now I'm not seeing my constant listed in the available fields. So I'll come back to the main activity class, and I'll see that I've marked my product ID constant as private. I'll move the cursor into the access modifier, that's the keyword private, and use an intention action and make it public. Then I'll go back to the detail activity and press Control Space, and there's my constant. So now I have the product ID, and from there I can get the product. My data provider class has a field called product map. That's a map of all the data objects with a key of string and a data type of product. So I'll go back to my detail activity class, and I'll use that map like this. I'll create a variable named product, typed as product, and I'll get its value by calling dataprovider.productMap.get, and I'll pass in the product ID. And now I have the complete complex object. And I'll add in the code to display just the product name. I'll create a reference to a text view object, and as always, I'll call findViewById and pass in the ID of the text view I want to use. It has an ID of nameText, and I'll cast the return as the appropriate type. Then I'll call tv.setText, and I'll pass in product.getName. And now I should be displaying the name for the selected product, and I'll run the code. And now when I touch an item, I see the actual name of the item I selected. I'll test the first item, then scroll down a bit. This time I'll choose polo shirt, and again I see the right value. And now I'm ready to fill in the rest of the visual controls. Fortunately, I already have code in place in one of my classes that does that, and so I'll just copy and paste some of that code. I'll go to my product list adapter class. First, I'll make a copy of this getBitmapFromAsset method. And I'll go back to my detail activity class, and I'll paste that into place. When prompted, I'll accept all of the recommended imports for the classes I'm referencing. Now, I'll need to make one change in this version of the method. When I call getAssets, I don't need to call getContext. I'm now calling this method from within an activity class, so I already know the context and I can call the method directly from the current class. Then I'll come back to my product list adapter class, and I'll select all of this code and copy it. Then go back to detail activity, and I'll paste that code here after the setup of the original text view. And once again, I'll accept all of the suggested imports. In this version of the code, I don't need to reference the view I'm looking for, so I can take out convertViewDot on both calls to find view by ID. And I have one more bit of data I need to display. Once again, I'll create a reference to a text view. This time I'll name it Desk View for Description View. And I'll get its reference from the ID description text in the layout file. Then I'll call deskView.setText, and I'll pass in product.getDescription. And now I have all the code in place to display the details for the selected data item. I have one error I need to resolve, and that came from an incomplete copy and paste, and I'll fix it just by adding the semicolon at the end of the line. I'll test to make sure I don't have any other errors by choosing Build and then Make Module. And if that completes, then I've resolved all of my Java errors, and I'll run the app again. And now when I touch an item, I'm seeing the name, the price, the description, and the image for the selected item. And I'll scroll around and test a few of them. And so those are all the steps you need to pass data from one activity to another. Again, you're using extras, and you can either pass a whole bunch of extra values, or as I did, you can pass a single primary key value and then use that value in the receiving or detail activity to go get the data you need. When working with two activities, you can return data from the second activity by packaging the data as intent extras, just like you do when sending it in the first place. As with the data you're sending, you'll need a constant for each extra that's accessible to both the sender and the receiver that's used as the extra name and identifies that value. I'll demonstrate this in the project Return Data, and I'll start in the main activity. I'm going to declare two new constants here. The first will be a private constant, and it'll be an integer that I name detail_request. This constant will be used to coordinate the two activities. When I launch the detail activity, I'll pass in this request code, and when I return from the detail activity, I'll be able to see it again, and I'll know where I'm coming from. The value can be anything you want, but it just needs to be unique within this activity. Next, I'm going to set up a string constant that can be used as an extra name, and this has to be visible to both the main and the detail activities, so I'll make it public. And because this is an extra name, it'll be a string, and I'll name it Return Message. This can have any value you want. It's just a constant, and I'll just use the same string as the name itself. I'll go down to my onItemClickListener method for the list view. This method is being called when the user touches an item in the list. And I'm launching my activity with this code, the startActivity method. In order to coordinate the two activities with each other, I'm going to change this method call to something called startActivityForResult. And I'll pass in the intent object just like before, but I'll also pass in my new request code, detail_request. And that's the initial work I need to do on the main activity side. I'll be coming back here in a moment, but now I'll go to the detail activity class. The detail activity is using this layout, activity detail, and I'll Control or Command click to jump to that. I'm going to change the purpose of the floating action button in this activity. Instead of an email icon, I'm going to display a shopping cart icon. And when the user touches the button, that'll mean add this product to the shopping cart. And I'm going to use the same shopping cart icon that I created and used in a previous video. It's in my drawable folder, and it's named IC Action Cart. Now, the size of this graphic isn't exactly perfect. If I were getting this application ready for production, I would create another version of this icon that was 24 by 24 dps. But this is good enough for this demonstration. Next, I'll change the code in my detail activity class so that when the user touches the button, I'll send a message back from the detail activity to the main activity. That code is down here, where I'm handling the click event on the floating action button. I'll get rid of this code that's displaying a snack bar message, and I'll replace it like this. First, I'll create an instance of the intent class, and I'll name that new object data. And when I instantiate it, I won't pass any arguments into the constructor. That's because this intent object is only going to be used to package up some data. Next, I'll call data.putExtra, and I'll pass in that constant that I created in the main activity class, named Return Message. That will identify the string that I'm passing back. Then I'll create my message. I'll start with the product object. Now, right now, the product object isn't visible to this inner class code, And I need to make a change up here to make it visible. I'll come back up to this declaration here, and I'll add final. By making this a final variable, it's now accessible to any code within an inner class, like this. And I can now say product.getName, and then I'll append a literal string of added to shopping cart. In a production application, I would actually save this data in a persistent data store, such as an SQL-like database. In this demonstration, I'm just sending the data back to the main activity. Now, I need to tell the main activity that everything was okay and the data can be processed. To do that, I'll call a method named setResult, and I'll use two arguments for this method. The first is a result code. I'm going to use a constant of the activity class called resultOK. Notice there's also one called resultCanceled. And then I'll also pass in my data object. And finally, I'll call a method named finish, and that means close the current activity and return to the parent activity. So these are the 4 steps. Create the intent object, use it to package up your data, and you could put more than one extra in if you wanted, set a result, and connect the data to the result, and then call finish to close the current activity and return to the parent. Now I'll go back to the parent activity, the main activity class. When you return to the main activity, you'll be calling a method named onActivityResult, and this is an override of a superclass method. So I'll type the beginning of the method name and then press Enter or Return to autocomplete it. I don't need to call the superclass's version of the method, so I'll delete that. Within this method, I first need to make sure that I'm coming from the expected detail activity and that everything is okay. So I'll use a little bit of conditional code for that. My outer if statement will check this condition. Request code equals detail request. The request code is being passed in as the first argument into this method, and I'm checking it against the constant I used when I requested the detail activity in the first place. I should receive it back again. Now, if that's true, I'll check one other condition. I'm also receiving the result code variable, and I'll check that against the constant resultOK. So now if both of those conditions are true, I can process the data. Remember, I sent the data using the constant return message, so I'll use that constant again to extract the data. I'll create a string variable that I'll name message, and I'll get its value by calling data.getStringExtra, and then I'll pass in return message. Data is the third argument that's being passed into onActivityResult. This is how I receive the data from the detail activity. Now, I could use a simple toast message to display that message to the user, but instead I'm going to do something a little bit more interesting. I'll once again use a snackbar message. I'll call snackbar.make. The first argument is a view, and as I did previously, I'll use the coordinator layout variable. Next, I'll pass in the message that I want to display. And then finally, a duration, and I'll use a constant of snackbar.lengthLong. Now, if you like, you can add some functionality to the snackbar message. I'm going to call the method setAction. And this will display a link on the snackbar message that lets the user take an additional step. I'll display a string of go to cart, and then I'll pass in an instance of the onClick listener interface. And I'll create that here. And that generates the onClick method. And here I'll just use a simple toast message to tell the user that they would have gone to the cart if this application were finished. And then finally, I'll complete the snackbar code with .show right down here. So reviewing all this code, first I check to make sure that I'm coming back from the detail activity and that everything's okay. Then I extract my message string from the intent bundle. Then I create a snackbar message and display it, but also allow the user to jump to another action by adding an action to the snack bar message. And now I'm ready to run the code. I'll scroll down a bit to an item that has a fairly short name, polo shirt, and I see my floating action button with the shopping cart icon. And when I touch it, I come back to the main activity, and I see the message, polo shirt added to shopping cart. I'll scroll around a bit more, and I'll choose another item, this time the thermal vest, and this time I'll touch the Go to Cart message in the lower right corner, and I see the reaction, the toast message. From there, if you wanted to create yet another activity, you could create the shopping cart screen and add persistent data storage to your application and build an entire e-commerce app. So that's how you send messages back and forth between the main and the detail activities. Intents can be used to package the data going in both directions.